Welcome to the Deep Dive. Today we're tackling something really fundamental to pretty much any modern app you use, APIs.
That's right.
We all know performance matters, right? Speed is king. And, well, a slow API can just tank even the best code.
Absolutely. It doesn't matter how clean your code is if the API itself is sluggish.
So the question developers always seem to be asking is, okay, how do I actually make my APIs fast?
And it's not just raw speed, is it? It's about scalability, responsiveness, the whole user experience. A performant API isn't some nice to have, it's really the core foundation.
Exactly. And for this deep dive, we've found, I think, a really fantastic practical guide for you. We're digging into battle-tested improvements, specifically for ASP.NET Core API performance.
Yeah, we're leaning heavily on a great article by Emanuele Bartolisi.
We are. But what makes this maybe a bit different is we're also weaving in some really crucial points and honestly surprising insights from the developer community right from the comments on that article.
Which is great because you get the core advice, but then you also get these real-world perspectives and refinements. It's like a peer review session.
Think of this as your shortcut, maybe.
Huh.
A way to get these actionable strategies and, a deeper understanding to help you build apps that are truly scalable and responsive.
We're aiming to give you that community-vetted wisdom, the stuff that really elevates how you approach performance.
And you should stick with us because, maybe surprisingly, we're even going to touch on how tools like, well, AI, GitHub Copilot can actually play a role here.
Yeah, it's not just for generating boilerplate anymore. It can actually help with optimization.
Definitely not.
Yeah.
Okay, so let's unpack this. Where do we start? What's the absolute foundation?
Well, the source really hammers home asynchronous programming. It frames it as basically non-negotiable for scalable .NET APIs. It's not just an option, it's pretty much a must.
And it makes sense why. If you have blocking calls lurking anywhere,
Yeah.
they can literally choke your thread pool.
Yeah.
Think of it like, I don't know, a highway, right? A blocking call is like a car breaking down in one lane. That whole lane stops. Everything backs up.
Yeah, it causes delays, kills your throughput. It's a major bottleneck.
And it's kind of frustrating because ASP.NET Core generally makes async programming pretty straightforward these days.
It does, but it's easy to fall into traps. The article specifically warns about using result or wait, if you see those, you're likely leaving performance on the table. Or worse, you could even cause deadlocks.
Oh, deadlocks. A developer's worst nightmare.
Exactly. But it's often more subtle, isn't it? Maybe hidden synchronous I/O calls deep in a library or in legacy code you're working with. That's where that thread pool starvation really bites you.
That's a great point. It's not always obvious. The get weather example in the article illustrates this pretty well, I thought. They show a bad version using result and then the good async version using await. It really highlights that you need to make the entire call chain async.
All the way through, from the controller, through your services, down to your data access layer. You've got to keep that async flow going.
Async all the way, as they put it.
Yeah.
Okay, so assuming we've got our async house in order, what's the next likely performance bottleneck?
Often it shifts to the data itself, how much you're fetching, how you're handling it, which brings us to smart data handling, starting with pagination.
Yes. The classic mistake of returning thousands of records in a single API call.
Yeah, nobody needs that entire table dumped on them.
Especially not on a phone. So pagination is the answer, delivering data in these manageable chunks. The article gives that clear skip and take example.
Standard stuff, but crucial. And a really good tip they add is returning pagination metadata.
Like the total count, current page size.
Exactly. That stuff is super useful for the front end, lets them build proper pagination controls.
It seems so fundamental, but I love that comment from the community someone shared. This developer was saying, I thought pagination was well known until I found systems literally pulling entire tables just to display them.
Yeah.
Arg.
Yeah, you see that. It really shows that knowing about something isn't the same as actually doing it consistently. It's easy to overlook the basics under pressure.
So true.
Yeah.
Okay, sticking with smart data handling, what about AsNoTracking in Entity Framework Core?
Right. So EF Core, by default, it tracks every entity it loads. This is necessary if you're going to say, change that entity and save it back.
It needs to know what changed.
Precisely. But for operations where you're just reading data read-only scenarios, that tracking is just, well, unnecessary overhead.
So AsNoTracking tells EF Core, hey, don't bother tracking this stuff, which optimizes the query.
And it's not just a tiny CPU saving. That change tracker can actually use up a fair bit of memory, especially if you're loading lots of entities. So it's a memory optimization too for reads.
Okay, that makes sense. But then the community comments added a really important layer here, didn't they? Regarding projections.
They did. This was a great clarification. The article mentions combining AsNoTracking with projections, where you select specific fields into a DTO.
Right.
But the key insight from the comments was, if you're already using a projection selecting only certain columns, not the whole entity, then EF Core is smart enough not to track it anyway. So adding AsNoTracking in that specific case is, well, implicit or maybe even pointless.
Ah, okay. So the projection itself effectively gives you the no tracking benefit if you're not pulling the whole entity. That's a fantastic nuance.
It really is. And props to the original author, Emmanuel, who mentioned in the comments he learned that point from the community feedback too.
That's awesome. Shows the value of that discussion. Okay, so we've handled async. We're fetching data smartly. What about getting that data to the client efficiently? Compression and caching.
Exactly. Let's talk compression first, Gzip or Brotli. The idea is simple. Make the response payload smaller before sending it over the wire.
What's the main advantage? And is there a downside?
The big win is reduced payload size, obviously. Huge for JSON-heavy APIs. Less data means faster downloads for the user. The trade-off, as the article notes, is it uses some CPU on the server for each request to do the compression.
Okay, so a CPU versus networks trade-off.
Pretty much. Though often this compression might happen at a gateway or load balancer level, not directly taxing your app server. And ASP.NET Core prefers Brotli if the client supports it, which is generally a bit more efficient. Setup's usually pretty easy too.
Got it. Makes sense, especially for users on slower connections. Now, caching. This is about avoiding hitting the database repeatedly for the same data, right?
Absolutely. Stop reloading the same data on every request. Use something like iMemory Cache for in-memory caching or iDistributed Cache for, well, distributed scenarios.
The article had that product service example. Caching featured products in memory for 5 minutes. Simple, effective for single instances.
Right. And it correctly points to tools like Redis when you're in a distributed environment, multiple instances of your app to keep that cache consistent across all of them.
Okay, standard caching patterns. But then, again, the community comments threw in something more advanced, hybrid cache solutions, like Fusion Cache or Microsoft's own hybrid cache. What's the deal there? Why is that an evolution?
This was a really insightful comment. See, traditional memory cache is fast, but it suffers from cold starts, empty cache after a restart, and it doesn't work well across multiple servers, horizontal scalability.
Right, each server has its own separate memory cache.
Exactly. Distributed cache solves the scalability but introduces network latency for every cache check, plus serialization, deserialization overhead. And crucially, neither typically gives you good stampede protection.
Stampede protection, what's that?
Imagine a popular cache item expires. Suddenly, all incoming requests miss the cache and slam your database simultaneously trying to regenerate that item. That's a cache stampede. It can overload your DB.
Ah, okay. Nasty.
Very. Hybrid caches aim to give you the best of both worlds. The speed of local memory cache, but backed by a distributed cache for consistency and scalability. Plus, and this is key, they often have built-in full stampede protection. Only one request actually hits the database to refresh the data, while others wait briefly.
Wow, okay. That sounds significantly more robust. And the comment mentioned the code stays pretty consistent, too.
Yeah, often you can add the distributed layer later without rewriting your caching logic entirely. It's a really elegant solution addressing the weaknesses of simpler caching methods. A brilliant point from the community.
Definitely feels like a step up. Okay, let's shift slightly to what data we're retrieving. Avoiding overfetching.
Super important. Overfetching means your API is returning more data than the client actually needs. Maybe your database entity has internal fields, sensitive info.
Things the front end doesn't need and shouldn't see.
Exactly. It's inefficient, pulling extra data, sending it over the network, and it can be a security risk, too. Principle of least privilege, right? Don't expose what you don't have to.
So how do we fix that? What's the pattern?
Data transfer objects. DTOs. Simple concept. Create classes that represent exactly the data shape your API consumer needs.
Like the article's example, the product entity has maybe internal stuff, but the product DT only has ID in name.
Precisely. Then you query your database, perhaps using projections, to populate these DTOs directly. You only fetch and send what's defined in the DTO.
It acts like a contract, defining the public shape of your data.
And a firewall, in a way. Prevents accidentally leaking internal details. Plus, it forces you to be intentional about your API design.
Makes perfect sense. Efficient and secure. And there was that quick side note from the comments, too. Use records for DTOs.
Yeah, a nice modern C-sharp touch. Good for immutability and cutting down boilerplate.
Okay, finally, let's talk about the AI angle. GitHub Copilot for performance. This one kind of surprised me.
Me too, initially, but the article makes a good case that it's more than just a code completion tool.
I tend to think of it for, writing boilerplate or maybe a new function. How does it help find performance issues?
Well, you can prompt it specifically for that. The article suggests prompts like, analyze this ASP.NET Core controller and suggest improvements for performance.
Okay.
Or even more specific, refactor this service class to reduce database queries, avoid overfetching, and use caching.
Oh, so you can feed it existing code and ask for optimization advice.
Exactly. The idea is it can spot common anti-patterns. It might detect blocking calls you missed, suggest adding AsNoTracking, maybe point out where pagination could help, or even offer refactoring ideas for complex methods.
That's actually really powerful. It's like having an AI pair programmer focused just on performance tuning.
Sort of, yeah. Like any tool, its suggestions need scrutiny, right? But it can definitely speed up the process of identifying potential wins. The more specific your prompt, the article notes, the better the results tend to be.
Fascinating. Okay, we have covered a lot of ground here.
We really have.
Started with the absolute must-do, asynchronous programming, avoiding those blocking calls.
Then into smart data handling pagination, AsNoTracking, and those critical nuances around projections from the community.
Right. Then optimizing the transfer itself, compression, and a deep dive into caching, including that evolution to hybrid caches.
Followed by precision in retrieval using DTOs to avoid overfetching.
And finally, leveraging tools like GitHub Copilot as a potential performance assistant.
Taken together, these are really solid, battle-tested strategies, as the article calls them. Applying them can genuinely help you build faster, more scalable applications.
And knowing this stuff, understanding the trade-offs and the community insights, really helps you stand out as a well-informed developer.
Absolutely. It's about continuous improvement.
You know, what really strikes me is that mastering performance isn't just about learning a checklist of rules. It's about understanding why they work, appreciating the nuances, keeping up with how the community refines these ideas.
And being open to new tools, like AI, that can help along the way.
Exactly. So maybe the thought to leave you with is this. Performance optimization isn't a one-time task. It's an ongoing process of learning, applying, measuring, and refining. Keep exploring, keep questioning, and keep building better, faster software.